So today's tutorial is going to be around drones and all the fun stuff that we can do with that, which we've been doing most recently on a bunch of the Shoto Greenway, aka Brickline work, and then also for the Tower Grove East Stream Restoration Project. Frank and I both took our licensing exam in like January. So you can fly recreationally without getting a license, but to fly for the enterprise, you have to get tested, pass, and then attend some training hours with Josh. So this isn't a process that everyone can do. But if you are interested in doing it, I'd reach out to Josh. I'm sure similar to last year, there's going to be some summer training hours or something. So you get a little bit of an overview of everything that we do. One of the main applications that we use is Drone Deploy. So this is the platform that you use to create your flight plan. Flight plan being essentially an automated flight path where the camera is at a fixed position and the drone is flying at a fixed height. And this is how we create sort of a repeatable way to gather a lot of information, aka taking a bunch of photos, which then get processed in another platform. So you create a new flight plan project in this application. It's essentially, think of it as like a lawnmower path. That's what you're seeing. And then you also have the ability to have it take an additional path around the perimeter at an oblique angle. Instead of the camera pointing straight down, it like points at a 30 or 45 degree angle, which is how it gets the imagery needed to create 3D structures. Typically, we'd use it for buildings, which we did for Cortex, or in the case of Tower Grove Park, we used it to actually get kind of a massing similar to what you would see in Google Earth of the tree canopy itself. Obviously, for higher resolution data, you would need to do laser scanning, but this actually worked really well for solar studies that we were doing. So once you do that, and you can even test the simulator on this, you would go out to the site, you plug your phone into the controller, you open this app after doing a bunch of pre-flight checklists, and then you kind of see what's happening on the screen now. And the drone starts flying, does its path. You are limited, obviously, in the sort of battery capacity. So it's a trade-off between how high resolution of imagery you want versus how many batteries you have versus the height of structures that you might be running into if you're flying too low. We typically fly at roughly 250 feet. So once you do that, you get 500, 700 images, so on and so forth. We have what's an enterprise connection with this other platform called Skycatch. And what happens is you take all those images, you upload it. 6 to 8 hours later, you get an email saying all of your data has been processed. And what it spits out is a bunch of different files. One of them, Frank had shown in one of our water coolers earlier in the year, is this high-resolution 2D ortho map. As you can see, what's on the left, granted, Google Maps is better than what they're kind of trying to show as Google Maps, but what you can get is this incredibly high-resolution ortho-rectified image, which means that the perspective has been effectively edited out. So even in Google Earth, you get kind of this annoying perspective shift sometimes with the side of buildings, especially tall buildings. you start to see the sides of them, which then you don't really know where the footprint is, and so on and so forth. So, you compare the resolution of this to the resolution of what we're getting, and you can see, we top Google Earth. So once you're here, there's also a 3D mesh that you can preview. And the nice thing about this web platform is it loads pretty quickly, so you can get a pretty easy preview of everything that you're looking at. It's a nice broccoli or cauliflower. Jury's still out on that one. But so you go back to 2D ortho map, and then you can download a bunch of different files. So the ones that we typically download are this orthomosaic TIFF, a digital terrain model as an LAS file at 25 points per meter squared, and a 3D mesh zip file. So for those of you that are familiar with LiDAR, it's basically just a point cloud model, and this digital terrain model understands things that aren't on the ground plane versus things that are, and it's kind of classified as such. So instead of, in a digital surface model is pretty much the same thing, except this has already been put into a mesh, or in this case, a raster file. By downloading this LAS point cloud file, it allows us to run the processing in ArcMap at whatever resolution we want, rather than being sort of pigeonholed into whatever they deem is the correct resolution. And then the 3D mesh comes in as an OBJ file, which you can open up in Rhino. So now I'm going to jump over to ArcMap. So as you can see, once you download that OrthoTIFF, this is what you bring it into ArcMap. This is kind of what you're left with. And if you note the units on the bottom, you can see that it is georeferenced. The georeferencing coordinate system that the drones use is not a local coordinate system. It's not the Missouri East FIPS that Frank was talking about and that we typically use for St. Louis projects. It is a global coordinate system, so it's UTM. But it doesn't really matter because both ArcMap and InfraWorks are smart enough to realize that and will automatically reproject it for you. So it's pretty smart in that regard. The other sorts of information that we get, obviously, is that LAS file that I was talking about. So you can't just bring in an LAS file, natively. You have to run a tool called create LAS dataset, which then you load that LAS file into it. It creates an LASD file, and then from there you would run. You change that LAS dataset into a raster, and what you get as a result is this filled raster, which you see here, which is effectively a terrain model that you can use in InfraWorks. So the pixel color relates to a height. Here you see it's still in meters. So you just have to make sure that your units in InfraWorks and units in ArcMap are aligned so that there's no sort of weird scaling issues. So looking at the last sort of data set that you download is this 3D mesh. So it comes into Rhino as an OBJ file, and then similar to the previewer that we just saw, you can 3D print it. Actually, I had done that for some of our tests that we had done in North St. Louis. I think they're in the office if you care to see it. But then we take kind of all of these data sets and bring them into an InfraWorks model. So this is kind of where we left off with in some of the training that Frank had done. So you're going to have some sort of building footprints layer. You're lucky it has a Z value that you've already done. Then you're going to have kind of a generic DEM model that you download from USGS. And then there's probably going to be some version of moderately high resolution aerial imagery, either from a local source, whether that's the city or county or state, might have access to that information. And then always some shape files around roads and, maybe if you're lucky, sidewalks in this case. And that's kind of where most of our InfraWorks models kind of start. So now we're going to be adding in the information that matters, or like why we even flew the drone to begin with. So I've already imported all of these things because it can take time. So I'm just going to be kind of turning these things on and off. But so let me surface layers and their ground imagery. So I'm going to turn on the orthophoto. And as you see, once this model regenerates, there's going to be that same orthophoto draped on the ground, and it's pretty much cut and dry as it relates to that. So I'll open up the actual model or the file itself. So as you can see, it's that UTM 8415 North. It's a raster. There's a little tip and trick. It typically comes in sort of with a black box around it. Show you that in ArcMap. So because it's just a square, so the trick is to turn on the alpha channel. You can do that both in InfraWorks and ArcMap, and that kind of just gets rid of that black bounding box. And then you just close and refresh, and it is pretty much just dropped right into place, and it's draped over the terrain that you had already put in place. There's some sort of issues that we've encountered depending on where we're flying. Sometimes the drone orthophoto isn't quite in the right spot. You won't really know that until you have an even higher resolution data set that you're referencing it to. So in the case of this project, we had gotten an actual survey from our client, Tower Grove Park, and I realized that the elevation contours that they're cutting for this channel weren't aligned with the orthophoto itself. So there's some sort of shifts that you have to do, which you can do in ArcMap. It's best practice or in the InfraWorks itself. The next thing which I'll turn on is the actual ground itself, that terrain. So let's see. So this is that filled TIFF that we took from ArcMap. And I'll turn off this east surface is the actual survey TIFF that we took from Civil 3D, which if you're curious about, I can talk more later, but not the focus of this tutorial. So let's take a second for it to regenerate. Shouldn't take too long. And there we go. So it's not perfect. There's sort of a weird thing that happens because we don't have, it doesn't know necessarily what's perfectly on the ground or at what elevation it should be. You get these instances at the edges of that flight path where it kind of tends to have a different elevation associated with it. And that the way to kind of rectify that Frank is better at doing than I am, and it's kind of an annoying workaround, but you have to apply a gradient in ArcMap to adjust the Z values, so that, because it kind of comes in at an angle and you have to kind of correct it. It's also a matter of just manually sort of adjusting the offset, the Z value of the data itself. So if I scroll down to the terrain, you can see that I put this Z offset just to get it up to relatively the same as the DEM that we're using for the rest of the context. And then the final thing is, and both of those come in, they're smart, they understand where they should be, it's all georeferenced. The thing that's dumb, because there is no georeference object, there's no points associated with it. Dumb isn't the opposite of smart, not as in the dumb feature, it actually is really helpful, is the actual 3D mesh itself. So let me turn that on as well. So as you can see, you bring it in as a 3D model. I brought it in as a road so I could turn it on and off. Downside to that is you do have to regenerate the model every time you turn it on and off. And there's better ways to do that. But as you can see here, it's a X, Y, M. So it's a manually defined X, Y coordinate system in meters. Meters because it's a UTM system. It's not a US feet-based model. And then you define the local coordinate system that you want it to be associated with. But in reality, that might have been a mistake to open this preview window. It comes in vertically, and you should preview this. And what requires is flipping this Y and Z value so that it is actually flat. And as you can see, it's at a 0, 0 value, a little bit below the surface, which is the same thing in Rhino if you look at the units here. So it basically just comes in as any generic 3D object that you then have to manually, through interactive placing, put on the site and adjust the Z value so that just the tip of the mesh breaks through the ground surface. And from sort of an urban design level of detail, when you're zoomed out kind of at this level, it really is sort of a nice sort of feature. You can test, obviously, if I bring in my sun and shade, you can see how most of the trees are going to cast shadow on the site, what areas are going to be exposed to the sun for most of the year. And then just through a series of, snapshots, you can just export, by turning off some of the layers. So you just see the ground, doing some Photoshop magic. You can have a really nice solar study. That's not going to be the same sort of thing that you run in Grasshopper, like what David showed last week, but more just a visual understanding of where you're going to receive the most sunlight, where you're going to receive most shade throughout the year. And obviously, as you zoom in, it gets kind of funky. And it starts to resemble, actually unfortunately, a little bit worse than Google Earth. But it's similar, it's actually the exact same process. A lot more frequently and a lot higher. But yeah, and then, you know, if you're lucky, as we were able to, and this is kind of digressing from actually drone imagery, is getting the point cloud information for the trees and stuff. And then that's when you can really start to have but in terms of best practices, let's back off and hide this mesh. So the big difference between, you know, the imagery that we captured from the drone and what we got from the city, I think it was in this case, or the East-West Gateway organization, they took it probably late fall, you know, winter, a sunny day. So what starts to happen is, you know, you get these dark shadows, the tree canopy isn't super defined, you don't really know where things are, it's just kind of messy, right? So this was a perfect example of, you know, the light, the quality of light that you want when you are flying. Basically, the cloud cover was at like 1,500 feet. It was overcast, but it was at like 11 o'clock in the morning. So it was still bright, but it was overcast. And what that allowed us to get is just this really flat, sort of soft, like light box quality, which allowed us to not have any harsh shadows, no dark shadows. And because it was in the early spring and everything was just starting to pop, you get a really nice differentiation of the canopy versus the ground plane, which has actually come in handy a lot as we've been trying to pick sort of a stream alignment through this space. We were able to see where the CAD file wasn't quite accurate. And we were also able to get information that would be really difficult to manually go and try to measure, you know, the boundary of each of these trees for, you know, the hundreds of trees that are in this park, or even in just this, you know, 50 acres. So it allowed us to, you know, not just use it for aesthetic purposes or solar purposes, but also kind of reinforce existing information that we were able to acquire through the clients. And it just happens to also be really graphic. But using it really as a tool and not just some additional service, but really letting it, you know, be able to inform our design process. And that is my fairly quick but concise overview of how we're using drone imagery in the Tower Road project.